Hey everybody, this is Larry. This is day 18th of the Advent of Code. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Hopefully my explanation if I didn't do the too poorly, and everything in between. Feel free to skip ahead if you're looking for an explanation. This is usually set up like the beginning is me solving a live. You see that I have a minute before we start, and as I say that, I'm going to transition into this so then you can see what I'm typing. I don't know. Yesterday's was kind of tough, so we'll see. But today, hopefully it's not too bad. Hopefully I get to spend my time packing. I took a nap after running 10 miles, which I don't know, maybe not the way to go. But yeah, we'll see. 35 seconds to go. Yeah, I hope everyone enjoyed yesterday. I actually find yesterday's fun, but just time consuming as well. And yeah, maybe on the weekend it'll be better. But I don't know. But this is maybe it. Maybe this is ramping up. So we'll see. We have 15 seconds to go. So let's go. 10. Let's go. 5, 3, 2, 1, go. I'm so confused. I mean, it is clearly like a shortest path, but what does byte 4 mean? I don't want to get this. People are already done with this farm and I'm just confused. Like, what does 4 mean? Why are you submitting only some of this? And also, yeah, I'm so confused. Okay, well, I guess we'll see. Yeah. I mean, this seems too easy. Is why maybe. I'm a little bit confused, but it's okay. Why would you submit only 12? That's what I'm confused about. But okay. Like I'm so confused. maybe I'm understanding this one. That's why I took a while, honestly, because I'm kind of very confused about this one. I mean, maybe having pre-win code would have been great. I don't know. It is what it is though. Well, just challenging myself, I suppose. Well, that's not great. Huh. Huh? Well, still not great. Okay, we're passing right, so what am I doing? Huh? Don't I push 0, 0? Oh no, you idiot. Okay, well, still wrong, but at least a little bit better. Maybe. I don't know what's going on. Is my library killing me? Just because of this thing. Same mistake twice. Maybe. Or maybe not, clearly. Tell me what is going on. I can't write a for loop anymore, apparently. Oh, what? I'm rushing it too fast. I can't be making mistakes on a breadth first search. It's just embarrassing. Okay. Why is this wrong? Is it a 6 by 6? They say. Did I misread part of this? Maybe I only need this first 12. Is that right? That's the part that I'm confused about. But what? Why? How am I? Why do I suck at this? Okay, maybe today's just not the day. I can write a for loop. I can't get anything done. 5 0. 1 2 3 4 5. Also, this is 7 by 7. Did I miss? Oh, 6 6. Okay, so I did mess this up when reading because I cannot read. Okay, so I got it. So now we want to convert it to 71 71. And we want to do 1024, they say, or something. Okay. Okay, well, that's not great. Oh, it's this thing which is r minus 1, whatever. Actually, the other one's wrong to 432. I don't know if this is right. Okay, that's way too slow, but that's okay. I mean, I knew I was too slow. I had to debug so many things. Okay. First byte, I would cut off the path to the exit. I mean, this is easy. This is binary search. If I was not so dumb on part 1, this would be done. I am just silly boy. Silly boy. Yeah. Something like this, right? if this is good, then we want to cut off less, right? If this is no good, we need more. So okay, yeah, and that's it. And that is the entire code mostly. I just have to put this in a good way. So again, if I had gotten part 1, this would have been way, and if I'm better about, you know, copy and pasting, this would actually be pretty good. Nope, don't print everything. That's probably not right for part 2. What am I printing? Oh, that was for part 1, I think. Okay. So this is, that means it's good. If it's good, we want to cut off. No, we want, if it's good, I mixed it up. Okay. 2904. I don't know if this is right. Oh, I mean, it's probably roughly right. Also, I don't need the binary search. I can just oh wait, the coordinates. Oh no, that was not even right. I mean, maybe that's right, but then the coordinates. I'm just rushing it clearly, right? 3831. I mean, I don't know. Today, some days are just not your days. I feel like, yeah, and you don't even need binary search. People probably already, you could do a linear search for it. 5 minutes. Yeah, it sounds about right, honestly. And I didn't even read the problem. I just kind of binary. I mean, this is such a trivial problem, though. But still wrong, clearly. Yeah. Well. So left is the first one where, is it maybe left -1? Because left, I don't know, I'm rushing it, that's why. But, I mean, I don't know. So left is the first, okay, so good should be, maybe I missed this one. So this means that this is, if good, that means it's cut off. If good is cut off, honestly, I don't even need to do it this way, but right. And this is much slower because it runs about 29 whatever, but like it should at least confirm whether my code is working or not. Maybe I should have kept the binary search actually. It's still the same. Am I misunderstanding the problem? I mean, I'm not even on the leaderboard, so I don't really, I'm like slowing down a bit. I don't know. Like I voted with binary search and I voted without it, and it still gives me the same answer, but the same wrong answer. Do I have anything else weird? No, I mean, it's just breadth first search, though I have messed up breadth first search as we saw. So adding this makes us not good, right? Is that the thing? I don't know why I'm struggling today. There's the first number that's not good. Okay. Oh, because that now is in it. Whoops. Not a good. I mean, at least it's fast. Or like today's easy. Just that I didn't get it that fast for whatever reason. Maybe I should print it out. Yeah, I don't get it. Like adding this line. Oh, inputs of target. I'm just being dumb. It's input targets -1 because it's the prefix that goes into it. Because 0. I'm just really bad today at the I'm just really bad at everything, really. And we even wrote the binary search. But I see it. Okay, 56. Yeah, I'm just dumb. Because I forgot that I wrote it this way, where I took the where I take the thing, so then target of 0 is actually 0 bytes and not the first byte. So I had an off by 1 in my head anyway. So yeah, I don't know, just one of those days. I just struggle so much when the breadth first search. I had like 4 different typos. So it was, and then the second part, I knew how to do it immediately, but then I just didn't even read it correctly, which is a little bit sad. Like I even wrote the binary. I returned the number of steps, which was 1, and then the second one I just apparently did this off by 1 thing. I don't even know how long time I spent, but it should have been immediate. Because it was just copy and paste, wrap a binary search. Oh, you can even write a for loop like I do, and it just doesn't even take that long. The binary search wasn't that long either, to be frank. So I don't even yeah, like this binary search is not that hard for me to write. So I don't even feel like usually you could say you know, it's a usually you can say you know, there's an analysis of cost-benefit analysis on whether to do it with like the smarter algorithm, but then taking time to write or whatever. So apparently today, maybe I'm just a little bit weird. Did something weird? Did I mess something up? Good man. Huh. Apparently I can't even write that anymore. But apparently I can't even do that anymore. But yeah, oh no, I wrote it right the first time, but then I changed it. But yeah, so that's, well, my point was to prove that it was easy to write. So for loop versus binary search actually didn't kill me that much time, but misunderstanding the problem and also just off by 1 did. Kind of rough day, because it's one of those problems. I don't know if I would honestly, you know, 3 minutes for part 1. I don't know, because I mean, I don't. It would have been hard, but it would have been very doable on a good day. But it's also kind of weird because, or not weird, just for me, like, yeah, there's ChatGPT people, but even without the ChatGPT, like a lot of top people have code for this, and this is also like the 10th grid problem or something like this, right? So like it's hard to be like, you know, like even if you didn't write a specific thing, like at the beginning of the thing, now you probably do. But also, even honestly, this is not that hard to write. I feel like I should have had it, but then I made like 4 different typos. Like I had a typo here, here. I had a typo here, and this one. So I have 3 typos. So which is terrible for code that I've written thousands of times, literally. So it's just one of those days, you know. And then part 2, well, I submit with the length instead of the coordinates because I didn't read, because I was like, oh, as soon as I saw it, I knew that I had to rush, even though I wouldn't have made it anyway, but it would have been very because I did so terrible in part 1, but it would still, you know, just gain some respectability. And I basically just wrote this, but then I submitted it wrong once, and then I got the right thing, but then I print out the wrong thing, and then I was debugging it, but that was more casual, so I don't know. Really disappointing Saturday, but it's okay. It is what it is. Let me take a sip, and then we'll go over the problem. Maybe running 10 miles is not a great idea for Advent of Code. The sacrifices we make for Advent of Code. Okay, so part 1. Honestly, at this point, there's not that much special, that many things special, because I feel like we've done this problem, this Advent of Code, literally, right? Maybe it's variation, sure, but it's still basically a grid shortest path problem. We have upper corner to bottom right, and you have these things, right? And though it's a little bit wonky, and that I think that, honestly though, if you rewatch it, that's why I was so confused in the beginning, because I was like, honestly, I was looking for a little bit deeper, and I thought that like we've done this enough times that I was just so confused. Like honestly, like yeah, I was kind of honestly a little bit confused that like it was that straightforward, and that kind of took me in a like a meta kind of way, took me for a pause, and you could kind of see it until I finally accept that, okay, it is like I didn't misread anything, it is exactly what I wrote. I also had another typo where I saw a 0 to 6 and 6 6 for example, but for some reason I changed that to the row and the height to be 6, which is my 4th typo for part 1. But yeah, but in any case, if you read this correctly though, it is just a regular application of breadth first search. Yeah, I don't really have much to add to this, and you know, and you don't even need breadth first search. You could do it with Dijkstra or something like this, and you would normally do it with Dijkstra if you're just implementing from scratch, probably. But like I said, many people probably have grid shortest path at this point set up, and you know, and yeah, and so maybe in that case you would just plug it into Dijkstra or your favorite algorithm. But it still should not have been that hard to write. I don't know if I could have gotten everything in 3 minutes, especially including all the reading. You know, people are very good at reading these days, apparently, especially when aided by machines. But yeah, so I don't know if I don't think I would have made the top 100 in either case. Well, maybe in the case where, you know, everyone reads the problem, but in any case, yeah, but definitely not today. On a good day, maybe. But part 2 actually kind of makes me sad that I got 2 mistakes. Like the code was actually, let's say 95% right. I just didn't print the right thing the first time. Oh yeah, I mean, let's go over it real quick. This part, the good function, is whether it's just connectivity. The thing about this connectivity is that as you drop more things, you can think of it as you know, it's a Boolean function where you can connect from the beginning to the end, and as you drop more things, well, it can only get worse in the sense that you can make it not connected, right? You could disconnect the graph, or at least disconnect the beginning to the end. there are actually kind of some fun algorithms you can play with this with respect to there are competitive programming problems, though we didn't do it that way because we don't have to. With respect to like, if you're disconnecting it from the top left to the bottom right, it also is equivalent to drawing a line that cuts the graph into two, right? Or the grid into two, which means there's a connectivity problem from like bottom to the right or bottom to the top, something like this, right? Which is actually kind of like a really cool way of doing it in linear time. If you're able to, let me draw it real quick. Linear-ish, say, with like whatchamacallit, union fine or something, right? And what I mean is that, let's say you have a huge grid. I'm not going to draw out all the grid, but you're trying to get from like here to here, right? So as we said, you know, there's some like funky path that I thought I changed the color. Why do they do this to me? I feel like, yeah, it's some funky path that goes whatever, right? This is how I get home when I had too many to drink, apparently. But also, yeah, as you kind of put in blockers. I'm just gonna draw an X. It's easier to draw. So like, put in like barriers or walls or whatever, then they get cut off. But another way to think about this is if you connect basically this side to either this side or this side, then you actually disconnect the graph. And what I mean by that is that if there's a line that goes like from here that goes here, then that means that of course the red line cannot pass without go through it, right? And almost equivalently, if there's a line that goes like from bottom to right, then you cannot do it. There's also other variations of this, which I should have drawn in different colors, maybe confusingly with green. You can imagine like something like this line. If you're able to draw this line, then you also cannot draw the red line. And using this idea, you could build a connected components type thing with union fine, and then you could just do it one at a time, which gives you a linear-ish time. I say ish because I guess if you really want to be pedantic about the inverse Ackermann function, which we will not go over in detail today. Anyway, so that's kind of like a fun up-solving thing that you can do. But for this one, suffice to say that you can actually do a linear search, right, and just output the right thing. Unlike me, my thing that's in common is a linear search, because I was just like, did I implement my binary search correctly? But you can also do binary search, because as I said, as you add more, eventually you'll disconnect the graph, so you could do binary search to kind of figure out where that point is, right? And this is how I write my binary search. And also, as I said, usually you have to choose a little bit, especially in advent of code, you have to choose a little bit about like how much time does it take me to implement, and how much time do I save. In this case, actually, I think it would have been roughly the same if I had it correctly, that is. But I write binary search pretty quickly at this point. The for loop is also quickly, but you have to wait, like, I don't even know how long it took, but it took a little bit of time, right? So I don't know for what that's worth. And of course, you can probably optimize some of the stuff if you really want to for linear search. In that, you can maybe do some. Actually, I guess another way that you could do it is actually in backwards, where you start with the graph disconnected. So then now you can actually draw a union fine as well, disconnect it, and then as you reconnect things going backwards, then now eventually you'll find the first point where it is connected, and then it's just a point after that or something. So you can actually do that as well without that funky idea that I talked about with union fine. So that's also kind of fun if you want to do that. Don't have that code for you. I'm not going to write it. I am already like kind of annoyed at myself, frankly. But these are some ideas that you can play with to optimize your code, or to play around this thing if you want to upsolve or whatever. But yeah, all that said, that's all I have with this one. Yeah, a little bit like, some days you just are not able to implement, and this is one of those some days. Seems like this year there are a lot of those days, though. I don't know. I think the other thing is that I think this problem feels very ChatGPT-able, so it adds to that pressure a little bit as well. But I mean, like I made two wrong answers on part 2. And I just took a long time on part 1, so whatever it is, it wasn't gonna be Gucci. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and yeah, tomorrow watch the video tomorrow. I'll be on the videos tomorrow. So yeah, thanks for watching, and I'll see you tomorrow. Stay good, stay healthy, to good mental health. See you later, and goodbye.